Let's move on to the second disclosure that we did as a part of this Christmas in July efforts at Searchlight. So the second one was NTLM credential leakage in DNN, which is formerly known as .NETNuke. A little bit more about DNN. It's a pretty popular C# based content management system, and it's been around for almost 20 years. It's ran quite heavily inside enterprises and governments. It provides a pretty rich content management layer. It's open source and has an active community of maintainers. And there's about 50,000 sites, give or take, on the external internet that are using DNN at the moment. So it's not a small footprint. There's definitely a lot of people still using this software even after 20 years. One of the things that we found really interesting when looking at the source code of .NETNuke and specifically looking at the pre-authentication attack surface of .NETNuke is that we just had a lot of background knowledge with how C# handles files. And we noticed some interesting code there. But before we get to that point, we want to explain some of the context around how C# or .NET, how files are handled with on Windows-based systems. And, it's kind of interesting because it's not limited to C# and .NET. Pretty much any programming language that's running on Windows has a really interesting way of dealing with files. And that's purely because Windows is quite unique in the sense that whenever Windows sees an SMB share as a file path, it actually tries to connect to that SMB share depending on what native libraries are being used. And Windows is quite unique in this factor because if there are any file operations in Windows that you can influence and make it connect to an SMB share, Windows will try and connect to that external SMB share and try to authenticate there as well. This is a native feature of Windows, so this flows through all file operations and programming languages, depending on what file system APIs they're using on Windows systems. The thing to watch out for whenever auditing .NET or C# applications on Windows, some common sinks include file.exists, system.net.http request, and system.net.webclient. It's quite likely that there's more sinks than this, especially those that interact with Windows file system or allow interaction with SMB shares. But this is a really interesting thing to remember and way more applicable, like broadly applicable beyond just .NETNuke. But we'll explain how this caused the major issue for .NETNuke as well. The other really interesting quirk of C# is basically the syntax of path.combine. Now, regardless of the fact that the C# documentation makes it extremely clear that this behavior is present, we see this behavior time and time again inside applications where they don't realize that this is what's happening under the hood. Whenever you use path.combine, especially when there's user input, if the second argument is an absolute path, then the first argument is entirely ignored, meaning that the second argument takes precedence. For example, let's say you had the first path being a base path that you statically define, and the second variable being user input. If you didn't make sure that the second variable was not an absolute path, the user input could completely override your static path that you set in the first variable. The way that this plays out is quite dangerous in C#, and I think that there are a lot of developers out there that aren't aware of this functionality of path.combine, especially given our experience with auditing C# applications. We see this quite often. So even though they've tried to warn people about it, it's something that we see quite often. We created a little bit of a diagram to explain how this plays out in practice and the dangers of path.combine. Basically, path traversal attacks, absolute path override, UNC path injection, and special character attacks. Really, path.combine shouldn't be used when concatenating two paths together, especially if one of them is user input. There are ways to do this in C# that don't rely on path.combine. And really, path.combine shouldn't be just accepting user input wholesale. It just concatenates paths without proper validation. And in the worst case scenario, it takes the second path as the source of truth if it is an absolute path. The other thing that we want to talk about, which will provide you context around how this vulnerability in DNN came to be, is the dangers of Unicode normalization. So if you take some sort of user input and you perform a number of security sensitive operations, and then you normalize that user input in any way, you might find out that you've unintentionally introduced some sort of order of operations bug into your code. Order of operations bugs are pretty tricky to identify, but they usually always lead to critical impact. And order of operations bugs are my favorite bug class. You would have noticed there's quite a few research posts we've done which focus on order of operations bugs. But this is exactly what happened in DNN. They sanitized the user input before making a file system call. But before making a file system call, they performed Unicode normalization. What you can see here is code from DNN or .NETNuke, where they take some user input, the file that's being uploaded, they get the file name, and then they do a bunch of sanitization through regex.replace. They validate the file name for having illegal characters, and they even clean the file name if it does, but then finally they make a call to convert those Unicode characters. And this is really where the unintentional chaos occurs. The call to path.getFileName ensures that only the file name is extracted, not an absolute path. The call to regex.replace is to ensure that potentially dangerous characters are replaced with underscores. And for validate file name and clean file name, there are defense in depth strategy to prevent any invalid file names. But the thing that's really funny is that they spend all this time preventing invalid characters inside file names, but then they finally apply a call to utility.convert Unicode characters, which in some essence reverses all of this effort that they did in the previous 3 steps or 4 steps. Because what you can do is essentially provide some Unicode characters that when they get normalized, they defeat the purpose of the previous security boundaries that they put in place. This is why this is called an order of operations vulnerability, because if they did the convert Unicode characters first and then proceeded with all of their security boundaries, they would have been safe. The normalization function itself, essentially it just normalizes it back to ASCII. So regardless of whatever Unicode is present, it's going to try its best to find the best fitting character inside ASCII. And as a result, this means that we can provide Unicode characters inside our file path name, inside our file name, that don't get caught by any of the previous security boundaries. But once they get normalized back to ASCII and find the best fitting character, they create a security vulnerability. The way that we exploited this was we used the full width full stop, which is a character that looks like a dot, and the full width reverse solidus, which looks like a slash, a backslash. But when these are normalized through the Unicode normalization process, they get converted to an actual dot and an actual backslash. It's quite interesting because what we can essentially do is influence the path.combine sync that comes shortly after this, so that it would reach out to our external server and leak NTLM credentials. So this is quite a neat trick. Again, this is something that can be applied well beyond .NETNuke or DNN. This is something that is something you should watch out for in any application that attempts to do any sort of normalization as well.